The Sun, our closest star, is a fascinating powerhouse that fuels life on Earth. It's about 4.6 billion years old and is located approximately 150 million kilometers away from us. That distance is so vast that light from the Sun takes about 8 minutes to reach our planet. Imagine that. Every time you step outside and feel the warmth on your skin, remember that it's a journey of 8 minutes in the making. The Sun is primarily composed of hydrogen and helium, with hydrogen making up about 74% of its mass. This massive ball of gas undergoes nuclear fusion at its core, converting hydrogen into helium, and releasing an incredible amount of energy in the process. This energy is what creates sunlight and heat, essential for life as we know it. Without the Sun, Earth would be a frozen, lifeless rock drifting through space. The surface of the Sun, known as the photosphere, is where we see the bright light that shines down on us. It has a temperature of around 5,500 degrees Celsius. But if you think that's hot, the core is a staggering 15 million degrees Celsius. That's where the magic happens, as the intense pressure and temperature allow nuclear fusion to occur. One of the Sun's most captivating features is its atmosphere, which consists of several layers: the chromosphere, the transition region, and the corona. The corona, the outermost layer, is visible during a total solar eclipse and can reach temperatures of up to 1 million degrees Celsius. Scientists are still trying to understand why the corona is hotter than the surface itself, a mystery that continues to baffle astrophysicists. The Sun also has a dynamic surface, often exhibiting sunspots, cooler areas that appear darker than their surroundings. These sunspots are caused by magnetic activity and can influence solar flares and coronal mass ejections, which are bursts of solar wind and magnetic fields rising above the solar corona. When these solar events interact with Earth's magnetic field, they can create stunning auroras, like the Northern Lights, which are a breathtaking display of nature's beauty. As we orbit the Sun, we experience the changing seasons, thanks to the tilt of Earth's axis. This tilt causes different parts of the planet to receive varying amounts of sunlight throughout the year, leading to the seasonal changes we all know. The Sun's gravitational pull also keeps our planet, and the other planets in the solar system in orbit, maintaining the delicate balance of our cosmic neighborhood. Interestingly, the Sun is not a static entity, it goes through an 11-year solar cycle, during which solar activity fluctuates. This cycle affects everything from satellite communications to power grids on Earth. Increased solar activity can lead to geomagnetic storms, which can disrupt technology and even cause power outages. In the grand scheme of things, the Sun is just one of billions of stars in our galaxy, the Milky Way. Yet, it holds a special place in our hearts and our lives. It's not just a source of light and warmth, it's a symbol of life, energy, and the interconnectedness of the universe. So, the next time you bask in the Sun's rays, take a moment to appreciate the incredible journey of energy that sustains us and the mysteries that still lie beyond our reach.
Mercury, the closest planet to the Sun, is a fascinating world that often gets overshadowed by its more glamorous neighbors. Imagine a place where temperatures swing wildly, where the surface is pockmarked with craters, and where a day lasts longer than a year. That's Mercury for you. First off, let's talk about temperature. Mercury experiences some of the most extreme temperatures in the solar system. During the day, the surface can reach scorching highs of about 800 degrees Fahrenheit. But when the Sun sets, temperatures plummet to a frigid -330 degrees Fahrenheit. This dramatic shift occurs because Mercury has almost no atmosphere to retain heat. It's like a cosmic desert, where the Sun scorches the surface by day, and the cold of space takes over at night. Now, let's dive into its surface. Mercury is a rocky planet, much like our own Earth, but its surface tells a different story, and it's covered in craters, remnants of violent impacts from asteroids and comets over billions of years. The largest of these craters, the Caloris Basin, is about 1,250 miles wide. Imagine a giant bowl carved into the planet, a testament to the chaos of the early solar system. The landscape is also dotted with long, steep cliffs called lobate scarps, which formed as the planet cooled and shrank over time. One of the most intriguing aspects of Mercury is its magnetic field. Unlike Venus, which is similar in size but has no magnetic field, Mercury has a surprisingly strong one. This magnetic field is about 1% the strength of Earth's, but it's still significant for a planet of its size. Scientists believe this magnetic field is generated by a partially liquid iron core, which is quite unusual for a planet that small. Speaking of its core, Mercury has a disproportionately large iron core that makes up about 75% of its radius. This core is surrounded by a silicate mantle and crust, making it the most metallic planet in our solar system. This unique composition raises questions about how Mercury formed and why it has such a large core compared to its size. Let's not forget about its orbit. Mercury has the most eccentric orbit of all the planets, meaning it doesn't travel in a perfect circle around the Sun. Instead, it has an elongated path that takes it closer to the Sun at some points and farther away at others. This eccentricity, combined with its rapid rotation, leads to some fascinating phenomena. For instance, a solar day on Mercury, defined as the time it takes for the Sun to return to the same position in the sky, is about 176 Earth days long, while a year on Mercury, or its orbit around the Sun, is only 88 Earth days. So, if you were standing on Mercury, you'd experience a sunrise and sunset that's quite different from what we see here on Earth. In conclusion, Mercury is a planet of extremes, from its temperature fluctuations to its unique geological features and magnetic field. It's a world that challenges our understanding of planetary formation and evolution. Each discovery about Mercury not only reveals more about this enigmatic planet, but also sheds light on the history of our solar system as a whole. As I think about the future possibilities between the Sun and Mercury, I can't help but marvel at the intricate dance of celestial bodies. Mercury, the closest planet to the Sun, is a fascinating subject. With its surface temperatures swinging wildly from scorching hot to freezing cold, it's a place of extremes. But what if we could harness the energy from the Sun in new ways? Imagine solar energy collection on Mercury. With its proximity to the Sun, Mercury receives about 7 times more solar energy than Earth. This could lead to the development of advanced solar farms, potentially powering missions beyond our planet. The idea of using Mercury as a launch point for deeper space exploration is tantalizing. With the right technology, we could establish a base there, using its resources to fuel spacecraft heading to the outer planets, or even beyond. Then there's the concept of terraforming. While Mercury's harsh conditions make it seem unlikely, what if we could create a controlled environment? Envision domed habitats that protect against radiation and temperature extremes. These habitats could serve as research stations, allowing scientists to study solar phenomena up close. We could learn more about solar flares and their impact on the solar system, gaining insights that could protect our technology here on Earth. And let's not forget about the potential for mining. Mercury is rich in metals and minerals, including valuable resources like lithium and rare earth elements. As we look to the future, the idea of mining these materials could become a reality. This could provide essential resources for technology on Earth and in space, reducing our reliance on terrestrial mining, which often has significant environmental impacts. The gravitational pull of the Sun also plays a crucial role in Mercury's future. As the Sun evolves, it will eventually expand into a red giant, engulfing the inner planets. But before that happens, we might witness dramatic changes in Mercury's orbit and surface. Understanding these changes could help us predict the fate of our own planet as the Sun ages. In the grand scheme of things, the relationship between the Sun and Mercury is a reminder of the vastness of our universe and the possibilities that lie ahead. As we continue to explore and innovate, who knows what we might uncover? The future is bright, and it's just waiting for us to reach out and
The
grasp it.
relationship between the Sun and Mercury is a fascinating dance of cosmic proportions. Mercury, the closest planet to the Sun, orbits at an average distance of just 57.91 million kilometers. This proximity means that Mercury experiences some of the most extreme temperatures in the solar system. On the side facing the Sun, temperatures can soar to a blistering 430 degrees Celsius, while the dark side plummets to a chilling minus 180 degrees. This stark contrast is a direct result of its thin atmosphere, which is unable to retain heat. Mercury's orbit is also intriguing. It takes just 88 Earth days to complete a full revolution around the Sun. However, its rotation on its axis is much slower, taking about 59 Earth days. This peculiar relationship means that a day on Mercury, defined as one full rotation, lasts longer than its year. Imagine that, a day that stretches longer than the time it takes to orbit the Sun. This phenomenon is known as a 3-2 spin-orbit resonance, where Mercury rotates 3 times for every 2 orbits around the Sun. The Sun's gravitational pull on Mercury is immensely strong, shaping its orbit into an eccentric ellipse. This means that Mercury's distance from the Sun varies significantly throughout its orbit, leading to variations in solar radiation and temperature. The Sun's influence also contributes to the planet's lack of a substantial atmosphere. Any gases that might form are quickly stripped away by solar winds, leaving Mercury with a surface that is heavily cratered and reminiscent of our Moon. Interestingly, Mercury also has a magnetic field, albeit a weak one, which is about 1% the strength of Earth's. This magnetic field is thought to be generated by a partially liquid iron core, which is quite unusual for a planet of its size. The interaction between Mercury's magnetic field and the solar wind creates a unique environment, leading to phenomena such as magnetic tornadoes. These are areas where the magnetic field lines twist and turn, creating swirling patterns that can accelerate particles to high speeds. The Sun also plays a vital role in the study of Mercury's geology. The planet's surface is marked by large cliffs, known as lobate scarps, which are believed to have formed as Mercury cooled and contracted over billions of years. The intense solar radiation has also contributed to the weathering of its surface, creating a landscape that tells the story of its tumultuous history. In essence, the relationship between the Sun and Mercury is a complex interplay of gravitational forces, temperature extremes, and geological processes. This tiny planet, often overlooked, offers a wealth of information about the formation of our solar system and the dynamics of planetary bodies. As we continue to explore Mercury, we uncover not just the secrets of this enigmatic planet, but also gain insights into the very nature of our solar system itself.
Imagine waking up tomorrow to find that Mercury, the smallest planet in our solar system, has simply vanished. No explosion, no warning, just gone. What would happen to the rest of the planets? Would Earth even notice? Mercury is the closest planet to the Sun, orbiting at just 58 million kilometers away. It's tiny, only slightly larger than Earth's moon, and has almost no atmosphere, no moons, and a gravitational pull that's too weak to significantly influence its neighbors. In fact, compared to the giants like Jupiter or even Venus, Mercury's gravitational effect on the solar system is minimal. So, if Mercury were to disappear, we wouldn't see immediate chaos. The Sun would continue to shine, and Earth would keep orbiting as if nothing had changed. However, its absence wouldn't go completely unnoticed. Mercury's gravity, while small, does play a role in balancing the orbits of Venus and, indirectly, Earth. Over millions of years, the removal of Mercury could lead to subtle shifts in the orbital dance of the inner planets. These changes would be tiny, nothing we would observe in our lifetimes. But over geological timescales, they might affect Earth's climate stability and increase the likelihood of close encounters between planets. For astronomers, the disappearance of Mercury would be a dramatic loss. It's a key object of study that helps us understand how planets form close to their stars. Without Mercury, we'd lose an important natural laboratory for scientific research. Additionally, ancient civilizations relied on Mercury's appearances in the sky for their calendars and mythology. Its vanishing would not only rewrite astronomy textbooks, but also erase a cultural link that humans have observed for thousands of years. Let's put things in perspective. If a giant planet like Jupiter or Saturn were to vanish, the solar system would spiral into chaos. Entire orbits would destabilize, leading to unpredictable consequences. But Mercury, it's so small that the solar system would remain mostly unaffected. In other words, while Mercury is important for scientific understanding, it's not crucial for our survival. So, if Mercury were to disappear, Earth would continue to orbit peacefully around the Sun. Life would go on, and we might not even notice right away. Yet astronomers would feel the loss deeply, because sometimes the smallest planets hold the biggest secrets about how our solar system was born.